over section 5.3 instead, or in a little bit of 5.2, I think. So I still have those. I'll get them back to you the next couple days. But in section 5.4, we are learning about something called sum and difference formulas. And there will be quite a few things that we get off of Handy Dandy. So I'll put some extras up here later if you need one. There they are. But the table at the bottom of Handy Dandy will be pretty helpful. Now, sum and difference formulas. That's what I need to give you first here. We can't do anything in this lesson without those formulas. So that's what I'm going to put on this very first slide here. Sum and difference formulas. These are not on Handy Dandy, and they won't be given to you on a test or a quiz. So I would put a real nice big star somewhere next to this in my notes, because these are formulas that I would want to put next time we have a test or a quiz on my cheat sheet. You'll definitely want to put these on there. Okie doke. First one we have is the sum formula for sine. If you look right here, there's a plus sign in the middle. That's the sum formula for sine. It says sine of u plus v equals sine of u cosine of v plus cosine of u sine of v. Now, the u and the v in all of these formulas is just going to be angles, two different angles. They might be in radians, they might be in degrees, but there'll be two angles. Now, what I want to tell you right now, before I forget to do this later, is that trig functions work differently than variables. Like a long time ago in algebra, you learned that if you had something like this, x times 2x plus 1, you could distribute the x and make it 2x squared plus x, and that was fine. You can't distribute like that when it's a trig function, okay? It's sine of this entire sum. You're not allowed to just take sine of u plus sine of v. If you look down there, that is not what they have. They've also thrown in some cosines. So the point is, you can't distribute a trig function like this, like you did a long time ago with x's. Okay, now I also need to give you the difference formula for sine. It says sine of u minus v, and that equals sine of u cosine of v minus cosine of u sine of v. All of the trig functions and all of the u's and the v's are in the very same spots. The only difference is that has a plus, that has a minus. Okay, so sum formula for sine, difference formula for sine. Let's do the same thing with cosine. I've got a sum formula for cosine and a difference formula for cosine. So let's start here. Cosine of u plus v equals cosine of u cosine of v minus sine of u sine of v. Now this one always kind of seems wrong because it's a sum formula, but you're actually subtracting. That is correct. Seems like it shouldn't be that way, but that's actually how it works. If you take the cosine of a sum, then it's going to work out like this. Cosine of u, cosine of v, minus sine of u, sine of v. Now, the difference formula for cosine has everything in the same spot, but now a plus sign in the middle. Okay, so cosine of u minus v equals cosine of u, cosine of v, plus, even though it's a difference formula, plus sine of u, sine of v. That looks good. Now we're going to do it one more time for tangent. We only have them for sine, cosine, and tangent. So these are the last two. And tangent is actually set up as a fraction. Tangent of u plus v equals tangent of u plus tangent of v all over 1 minus tangent of u tangent of v. Notice the tangents on bottom are right next to each other. That means they're getting multiplied together. Same with all of those. The trig functions that are right next to each other, that means they're getting multiplied together. These are not. These are being added, but down here those two are being multiplied. Now, last one, again, these would be excellent to put on a cheat sheet. Next time you have a quiz. Tangent of u minus v equals tangent of u minus tangent of v all over 1 plus tangent of u, tangent of v. Again, everything's in the same spot, but the signs have changed. Now there's a minus on top and a plus on bottom. Okie doke. So those are going to be what we're working with all day today. Sum and difference. Sum and difference. Sum and difference. We got it for sine, cosine, and tangent. Now, the directions today, I think there's a couple different sets of directions. Did everybody get those formulas, I guess, before I move on to this? Okie doke. First set of directions says, find the exact value of each expression. Find the exact value. So we're not just typing this in to a calculator. We're going to actually figure out what it is exactly. Now this looks kind of weird, but this is example 1, part A. There will be a part B to this here in a minute. But for part A, we need to figure out sine of 3 pi over 4 plus 5 pi over 6. Now again, you're not allowed to distribute a trig function like this. This is not the same as sine of 3 pi over 4 plus sine of 5 pi over 6. I'll show you that here in a little bit. But what we have here is sine of a sum. And so if you look at those 6 formulas that you wrote down, first of all, you need to be looking at the sine formulas, because that's what you have out front. And the one that you want has the plus sign. Sine of u plus v. That is the formula that we're going to use right here on part A. Again, the u for us would be 3 pi over 4, and the v for us is 5 pi over 6. Now, I just need to follow this right-hand side and put everything in its place. So let's look at the formula here. Sine of u, well, u for us is 3 pi over 4. So that needs to say sine of 3 pi over 4. right next to that, so multiplied by that, is cosine of v. V is 5 pi over 6. So that needs to say cosine of 5 pi over 6 plus cosine of u, which is 3 pi over 4, times sine of v. For us, that's going to be sine of 5 pi over 6. I basically just put all the sines and cosines in their places and all of the u's and v's in their places. Now, we take good old handy dandy and we start to look all of these values up. Let's start with this one. Sine of 3 pi over 4. I'm going to look at the sine row. I'm going to look for the 3 pi over 4. I'm going to make my fingers meet in the middle. Sine of 3 pi over 4 should be radical 2 over 2. Notice I put it in parentheses because it's going to get multiplied by this next part, which I'm also going to find on handy dandy. Cosine of 5 pi over 6, that would be negative radical 3 over 2. Now there should be a plus sign next, and let's fill everything else in. This can come off of handy dandy. Cosine of 3 pi over 4, that is negative radical 2 over 2. And then last part, sine of 5 pi over 6, that should be a 1/2. Okay, any questions about how we found those numbers? All right, well, we need to make this look better. These two fractions can get multiplied together, and then those two fractions are going to get multiplied together. Now, multiplying fractions, you can go across the top and across the bottom. So I do notice this is a positive times a negative, which will make a negative. And then square root of 2 times square root of 3. It's been a little while since we've done something like that, but as long as they're the same type of root, you can just multiply together the numbers underneath. That can turn into square root of 6. And then on bottom, 2 times 2 is 4. You don't need common denominators when you multiply fractions. It just so happens that we did have common denominators, but they still get multiplied. Now, same kind of thing over here. A negative times a positive is a negative, and I'm not going to put plus negative for my signs. That would look kind of weird. Anytime I add a negative, it's the same as subtracting. So let's just put a minus there. And then across the top, across the bottom, square root of 2 times 1 is just square root of 2. 2 times 2 is 4. Now, there's one more thing that I'd like for you to do here. If your denominators are the same, which a lot of times they will be, if they are the same, go ahead and turn those two fractions into just one fraction. So I put the 4 on bottom, and then you can just take negative square root of 6 minus square root of 2. You can't really subtract those. In order to add or subtract radicals, they have to have the same number underneath. So those do have to stay separate, but if it's already a common denominator, go ahead and stick it back together. We're finding a single value anyway, so it kind of makes sense just to have one number. Okie doke. Any questions about how we did part A? This was sine of a sum. So that's why we used that formula. Now take a look at part B for this problem. It looks similar to part A, but it's not the sign of a sum anymore. It's sine of 3 pi over 4 plus sine of 5 pi over 6. You don't need a fancy formula for this. We can just look those up on Handy Dandy. Or actually, we probably looked them up earlier on part A. But sine of 3 pi over 4, that is radical 2 over 2, plus sine of 5 pi over 6, so that's plus a half. And same deal here. If your denominators are already the same, keep it and make it one single fraction. You do need to put the plus 1 here. So either radical 2 plus 1, or if you want to put 1 plus radical 2, that would also work. Now, the reason we have part A and part B on this is because we're trying to just prove that you can't distribute a trig function. If you go back to part A, and remember I said earlier, it's not the same as sine of 3 pi over 4 plus sine of 5 pi over 6. If you distribute the trig function, it would look like that, and you get back this answer, square root of 2 plus 1 over 2. If you don't distribute, because you're not supposed to, and you use your formula like you should, you get back a completely different answer. So really the answers for part A and part B on these should always be different, because you're just showing that you can't distribute a trig function. Okie doke. Let's try just one more like this. This is example 2, part A. Cosine of 2 pi over 3 minus pi over 6. Okie doke. I need to look for my formula first. I see cosine out front. So look at the third and fourth formulas that I gave you earlier. But this is cosine of a difference. There's a minus. So when you look at your formulas, you want this one. Cosine of u minus v. U for us is 2 pi over 3. V is pi over 6. Okay, now we have to just put everything in its place. Let's get started. Cosine of u, that is cosine of 2 pi over 3. Right next to that, I need cosine of v, and so that turns into cosine of pi over 6, plus sine of u, so sine of 2 pi over 3, times sine of v. That is sine of pi over 6. Okay, well, hello, handy dandy. We meet again. I've got 4 more things to look up. Cosine of 2 pi over 3, that is negative 1/2. It's going to get multiplied by cosine of pi over 6, which is radical 3 over 2. Then I need to add sine of 2 pi over 3, which is square root of 3 over 2 again, times sine of pi over 6, which is 1/2. So it's a lot of the same steps to simplify. We want to multiply the fractions together and then hopefully put it all together as a single fraction. Okie doke. So up front, negative 1/2 times radical 3 over 2. That makes negative radical 3 over 4. Plus, well, this is interesting. plus radical 3 over 4. That, I mean, you could try to turn it into a single fraction if you want, but you're going to get 0 on top. Negative square root of 3 plus square root of 3, that's just 0. And 0 divided by anything is 0. So all that work, and we get back a 0. That would be our answer for part A. Now on part B, when it looks like we've distributed the cosine, we should not get back 0 because you can't distribute a trig function like that. So let's do it. Cosine of 2 pi over 3 minus cosine of pi over 6. This is much easier and much faster. I only have a couple things to look up, and you've actually already looked them up, I'd say, from part A. Cosine of 2 pi over 3 is negative 1/2. Subtract cosine of pi over 6, which is radical 3 over 2. And again, if you have common denominators, go ahead and put it as a single fraction. The 2 is still on bottom, and we've got negative 1 minus radical 3 on top. Okay, first couple problems here are mainly just getting used to using those trig functions or those trig formulas, sum and difference formulas. Any questions on that? Okie doke. There's only one more example today, but the directions do change for this last one. And it says, find the exact values. Find the exact values of sine, cosine, and tangent. One example sounded pretty good, but then I read the directions and I find out there's 3 things to do for each one. So one more example, but there's a few parts to it. Okay, so here it is, number 3. It's going to be given to you kind of like an equation. It is an equation. 165 degrees equals 120 degrees plus 45 degrees. We have to find the sine, the cosine, and the tangent of this equation. Now, we should just start with sine. Okay, what I'm going to do first here is basically take the sine of both sides. So to do that over here, I'm just going to put sine in front. And to do it over here, it's pretty much the same thing. Just put sine in front, although you should put the 120 plus 45 in parentheses, since it's sine of the whole thing. Now, to finish this problem, I'm not really looking at this side anymore. If you look at your handy-dandy table, is 165 degrees listed in your table? No, you go from 150 to 180. 165 is not on there. So the whole point of these problems is to take an angle that we're not as familiar with and break it apart into 2 angles that we are familiar with. Is 120 and 45 on your table? Yes, so we can work with those. But remember, sine of a sum, you're going to have to use your sine of u plus v formula. The u in this problem is 120 and the v is 45. So let's go ahead and start to use that. The formula, I don't have it up here, but you've got it in your notes. It starts out with sine of u cosine of v, so for us, sine of 120, cosine of 45, plus cosine of u, sine of v. And again, because these angles are broken down, it's not the 165 anymore, it's 120 and 45. Now I can look those up on my table. Sine of 120. We were in radians earlier, but the degrees should be just below the radians. You can look right underneath of there. Sine of 120 should be radical 3 over 2. Cosine of 45 is radical 2 over 2. Then cosine of 120, that is negative 1/2. And sine of 45 is another radical 2 over 2. So we just have to simplify this like we've been doing on all the rest of them. This turns into square root of 6 over 4. I'm not going to put plus negative here. I'm just going to put minus square root of 2 over 4. Then keep the denominator the same, and you can put square root of 6 minus square root of 2 all over 4. Sum and difference formulas are helpful when you are working with an angle that you're not as familiar with. 165 was not a real nice angle, but 120 and 45 are. Now, unfortunately, we're not done. That was just sine. We still have to do cosine and tangent. So this is a 3-slider here. I think I'm taking up 3 different slides for this problem. Cosine of 165, you really don't even have to write that part down anymore if you don't want to. We're going to be doing this side. Cosine of 120 plus 45. So on this problem, I'm using my cosine of u plus v formula. Cosine of u plus v. U is 120, 45 is the v. So here it is. Cosine of u, cosine of v. So that's cosine of 120, cosine of 45. It was a plus, but remember the formula actually wants a minus. And then sine of u, sine of v. That is sine of 120 times sine of 45. And here it goes. We could reuse, bless you, we could reuse some of those from earlier probably, or you can look them up again. But cosine of 120 is negative 1/2. Cosine of 45, that is radical 2 over 2. Then sine of 120 is radical 3 over 2, don't forget the minus, times sine of 45, which is radical 2 over 2. Now multiplying all of that together, I get negative radical 2 over 4 minus radical 6 over 4, but we want to put it together anytime we have a common denominator. So that is negative radical 2 minus radical 6 all over 4. Any questions about the cosine in this problem? Okey-doke. Now one more part, tangent. We haven't worked with tangent yet today, so this might be slightly new, but I need to take tangent of 120 plus 45. Again, I'm not really looking at that anymore. I'm looking over here, and I notice the plus sign. So as I do this, I'm using the tangent of u plus v formula. This is still u and that is still v. All right, it was in fraction form. On the top of the fraction, you have to take tangent of u plus tangent of v. So that's tangent of 120 plus tangent of 45. Now on bottom, you have to take 1 minus tangent of u times tangent of v. So I've got 1 minus tangent of 120 degrees times tangent of 45. Let's start to fill all of this in. Tangent of 120, where are you? There you are. Negative radical 3 plus tangent of 45, which is 1, all over 1 minus tangent of 120, which again is negative radical 3 times tangent of 45, which is 1. Now, a lot of times the only mistake that I see with these problems is a sign somewhere, not S-I-N, but S-I-G-N, like a positive or a negative somewhere. So just be careful on bottom. This multiplies out to just be negative square root of 3, but you don't want to put 1 minus negative square root of 3. Let's put 1 plus square root of 3. Now, I realize it's very tempting to try and cancel something out. You see the 1s and you see the square root of 3s and you just want to cancel them, but you actually can't, because this is a part of a sum, that's a part of a sum. If you canceled something, they would all 4 have to have it in common, and they don't here. So I would just leave this the way it is. Now, the back of the book probably rationalizes the denominator or does something else fancy that I'm not going to ask you to do. So it may be hard to check the tangent answers in the back. We'll go over those more together tomorrow. Any questions on that? Alrighty. So there's only 5 problems here. You've got like 15 minutes left, so you could probably finish this. But I just went through and picked the good ones that I saw. It is T40, and we'll probably have a binder check at some point this week, I would say. From page 381, we're going to do 9, 11, 12, 13, and 15.